Hey there, this is a video for my grade 12s. Just checking the audio here, we're good. This is me making an answer key for the 5.4 practice quiz. This should actually say part 2. There's a couple of typos here. This should say part 2. And actually, this question here says you're asked to graphically, and then next indicate the solution graphically. Well, that's supposed to say algebraically. Sorry, I don't know what I was thinking when I typed that. So anyway, this is the key. And okay, so first of all, we're going to graphically solve for the cosine of theta equals negative 1/2. And I'm telling you right now, we're going to cheat, because we're going to do this as two graphs. We're going to graph y equals the cosine of theta, and we're going to graph y equals negative 1/2 and figure out where they meet. All right, this grid isn't all that helpful. It doesn't give us exactly negative 1/2. I want a fairly accurate graph, so I'm going to kind of measure it. That's about 2.3, 2.2, so I want to go about 1.1 or so. So there, something like that. That's about where negative 1/2 is. So I'm going to make a line there and finish it off over here. There we go. So there's y equals negative 1/2. Now we're going to graph y equals the cosine of theta. Now the cosine of theta, the b values and c values and d values are nothing. The a value is 1. Actually, the b value is also 1. So that means it's just your standard cosine graph, which starts at its maximum when theta is 0, and then it goes back to its maximum in one period, which is 2 pi. And that means it hits its minimum at pi. It will hit its central axis at pi by 2, and then again at 3 pi by 2. And that's about all that I really need to make a sketch of this. And let's see. I want to make this fairly accurate. I'm going to use a pencil in case I goof it up and need to erase it. So I'm going to make that. See, I already don't like that. It's going to be too pointy. It's got to be a curve. Oh, I like that better. There we go. Beautiful. And from 0, put those dots end the graph because our domain is from 0 to 2 pi. So I don't have to go any further than that. So there we go. There's my graph. A little bit of a hiccup there. Sweet. Now, my two solutions are here and here. And remember, I told you I was going to cheat? Well, here's me cheating. I actually happen to know, and you do too. In fact, we'll solve the second part of the question, and that'll actually tell us exactly what those x-coordinates are. So the second part of the question is to solve algebraically. Okay, so when is the cosine of theta equal to negative 1/2? Think back to chapter 4. Cast rule, so cosine's negative here and here. And at pi by 3, we have an x-coordinate of 1/2. So this will be 2 pi by 3 will be one of them, and 4 pi by 3. So that's my two solutions. Theta is 2 pi by 3 and 4 pi by 3, and that's what those things are. And you can kind of tell. I mean, this is counting quarters. So if you count it in thirds, which would be a little bigger than a quarter, but not much, that distance there, again, gets you to here, and then that distance there, again, gets you to here. Get it? 1/3, 2/3, 3/3, and then again, 4/3. So it's pretty close. So, whoops. 2 pi by 3 and 4 pi by 3. And then that'd be comma negative 1/2 is this point, comma negative 1/2 is that point, and the x coordinates are the solutions. Remember, we don't want the y coordinates because there was no y in the equation originally. We invented that. So really we want to solve for theta. Remember, so this is my theta and this is my y, and the theta coordinate is what I'm looking for. So there's question number 1. Fairly simple one. Question number 2 is basically the same, only tougher. And this time they want us to do the algebra first. Okay, so let's do the algebra first. Remember that the idea here is to let theta equal this oogly bracket. So then I'm actually solving 3 cos theta, negative 3 cos theta minus 1 equals negative 4. So I'm going to add 1 to both sides of the equation, like a good algebra student. I'm going to divide both sides by negative 3. And then I'm going to break out my unit circle again. When is cosine equal to 1? Well, that happens here at 0 and 2 pi. So I'm supposed to go between the interval of 0 to 8. But remember, that's the interval for x. So just keep in mind that I can't go past 0 on the left or 8 on the right algebraically or graphically. And algebraically, I have to solve. I'm going to solve for those two answers and see if there's any more possible answers. Because remember, this would also be the same place as 4 pi and negative 2 pi, you know, depending on how many times you want to spin around. But I always start with kind of those two. So theta could be 0 or theta could be 2 pi. So I'm going to start with those two answers. So remember, I wasn't solving for theta, I was solving for x. I substituted in theta for this expression in terms of x. So I'm going to replace my theta again with what it was, which was pi by 2 times x minus 3. So that equals 0. Divide both sides of the equation by pi by 2, and x minus 3 is 0, so x is 3 is one solution, and that's between 0 and 8, so that's a good solution. And then I'm going to replace this theta with what theta actually was. Oh, my screen froze. Let's give it a sec. There we go. And then I'm going to divide both sides of this equation by pi, times both sides of this equation by 2, and x is equal to 7. And that's within my range as well, but I can tell right away that if I were to go to 6 pi, that'd be too big, and if I were to go to negative 2 pi, this would be too small. So that's it. That's my only two answers. There they are. And now we got to do that graphically. So let's see. Graphically. All right, so we are graphing two equations again. We're graphing, let me just move that down a bit. We're graphing y equals negative 4, which there we go. Easy enough. Seem to be freezing a lot today for some reason. There we go. And we're going to graph now y equals negative 3 cosine of pi by 2 x minus 3 minus 1. Okay, so a is negative 3, d is negative 1. So d is negative 1, so that's my central axis. I might as well make a dotted line for that. Again, I don't know why I'm freezing so much. I wasn't having this problem earlier today. And a is 3, which means, actually you can ignore the negative. The negative just tells us which direction the curve is going. But the 3 tells us that we go up and down 3 from here. Well, going down 3 takes me to here. So actually I know that my solutions are going to be on the minimum. But the maximum go up 1, 2, 3, and that'd be this line here. Okay. Now, my c value is 3, so that means that, again, cosine starts on its maximum unless there's a negative in front of it, in which case it's a mirror image in the central axis, which means that it actually starts on its minimum. So it starts on its minimum at 3, right there, which, by the way, was one of our solutions. And then I need to figure out how many loops it makes, so how many cycles it makes. So I kind of need to figure out my period, knowing that b is pi by 2, and that period is 2 pi over b, which is going to be 2 pi over pi by 2, which is 4. So that means that it makes one complete cycle in 4 units. So it means if it starts here, 1, 2, 3, 4, it ends there, and there's my other solution, but I might as well finish this off. I was supposed to actually graph this from 0 to 8, so let's do that. So that means that there's another solution, or there's another minimum 4 units this way, 1, 2, 3, and that's actually outside my solution, but I'll graph from there to there and then decide the solutions after. So if that's my minimums, my maximums happen halfway between those dots, which would be there, 1, 2, 1, 2, and there. And my places where I cross my central axes, also known as the node points, would also be halfway. I think I am ready to make a curve. Once again, I'm going to go to a pencil just in case I goof it up. So let's see, we're going to go, oh wait, see, I've already goofed it up. Remember, I'm actually stopping at 0, so I don't need to go past 0. So this is 0 right here. So let's see, we can go. we go to 8. Boom, there it is. From 0 to 8, we have 2 places where our lines meet. So this is the line. You can label it y equals -3 cos pi by 2 x minus 3 minus 1. And my 2 solutions are here and here. My solutions are x equals 3 and x equals 7. And there you go. If you can do a question like that, that question like that would not stump you on the test. That's about as hard as these get.